Select the major product of the following series of reactions. So if we take a look at our starting material, we see we have a molecule that contains two ketones. So we should be thinking about the chemistry that goes along with ketones, particularly if we have two of them. And then we see our reaction conditions. We're treating this with aqueous sodium hydroxide followed by aqueous acid and heat. These are the conditions together for an aldol condensation reaction. And specifically, we have the two ketones in the same molecule. So this is going to be an intramolecular. So intramolecular meaning within the same molecule aldol condensation. So what we want to think about here is we can have an intramolecular reaction. It's going to form a ring. So this will happen if we can form a 5 or 6 membered ring. So that's what we want to look for. So 5 or 6 members to this ring. So when we do an aldol reaction, we're deprotonating the alpha carbon of one of our carbonyl compounds, our aldehyde or ketone, and attacking the carbonyl of the other. So I want to count to see whether I'm using this alpha carbon or this one, which is exactly the same as on the other side of the molecule, and see which one of those attacks would give me a 5 or 6 membered ring. So if I start from here, and I deprotonate, and this were to attack the other carbonyl, we would have 1, 2, 3, 4, 5, 6, 7. So that's probably not going to work too readily. So we're going to go to the next alpha carbon. And if we did the deprotonation here, we would have 1, 2, 3, 4, 5. So that should work. So I'm not going to draw the entire mechanism. I'm just going to show the attack. So after you've deprotonated and made the enolate on carbon 1, this can swing around to attack that carbonyl at carbon 5. And this can bend. These are all alkyl groups, so they can actually get very close in space to be able to do this reaction. So this is after the first step with your sodium hydroxide and water. And again, I'm not going to draw the whole mechanism. This is going to be an aldol addition, so I'm going to go ahead and draw the aldol addition product. So I'm going to start by drawing the 5-membered ring, and I'm just going to number the atoms 1 through 5. And so carbon 1 is where I have this ketone outside of the ring. So in case you were wondering why I didn't count these atoms, it's because I was only counting the atoms in the ring. We're treating everything else as substituents off of the ring. And so after this attacks carbon 5 and you add a proton back on, you're going to have an alcohol attached to carbon 5 and you're going to have a methyl group. So that would be the aldol addition product from that first step. And then when you heat this up with aqueous acid, it's going to dehydrate, which will give you an alkene. And so where the alkene is going to form, so you're losing this and you're losing a hydrogen, you're going to form your alkene between 1 and 5 because now it's conjugated to the carbonyl. So from your aldol condensation, you're going to get this alpha beta unsaturated carbonyl. And then if you look at the next step, we're treating this with an organolithium reagent, or this is specifically a Gilman reagent. So I guess I should have said copper lithium. I apologize. So this dialkyl copper lithium reagent, otherwise known as a Gilman reagent. So this is a nucleophile. So we have 2 electrophilic sites on our molecule. We have the carbonyl and the beta carbon. Your Gilman reagent is a softer nucleophile, and this will add to the beta carbon. So this is going to add to the beta carbon, which is going to give you, I guess we've added another methyl group, so not very good at bond angles, but hopefully we can still pick out the answer. So we're looking for the 5-membered ring where we have a ketone and these 2 methyl groups right adjacent to it, so we can see that option is C.